Hello and welcome back to Urchin Studios in London. My name's Dan Cox and today we're going to talk about making your own guitar leads. Now, just before we get into how to actually do that, I'm just going to very briefly mention a few of the reasons why you might want to build your own leads. Now, the first reason is cost. When you go down to a guitar shop or go online and you buy a lead, you're essentially paying for somebody else's time to assemble those parts for you. When it comes to building your leads yourself, you're buying all the parts individually, and you can do things like buy a big old reel of cable and you assemble it yourself, so you're not paying someone else's labor fees, you're paying yourself in the time and money saved. Now, talking about big old lengths of cable, what's really handy actually is you can make the leads whatever length you like. Now, my sort of favourite guitar length lead is this, which is about 3 or 4 meters. I've got loads of other ones that are all sorts of different lengths, and it just depends. Perhaps you're building a lead specific to the distance in your studio from you to the equipment, or perhaps you want a really, really long lead for on stage, for running about all over the place into the audience, up into the balconies, etc. Also, you can decide on the colour. You don't just have to have a black lead. You can make a white lead, or you can make a yellow lead, or a red lead, or whatever colour you want. Also, by learning to put the cables together yourself, you're also going to learn how to repair them when they go wrong, and this is a massive money saver. Before I learned how to do this myself, I'd buy a cheap cable, I'd use it for a bit, I'd thrash around on stage, and I'd break it. And then when I broke it, I'd go, I've broken that now. Go and spend another 10, 15 quid on another lead, thrash around with that for a bit and break it. Now I know how to build these cables, I know how to repair them myself. And also, just to mention, of course, once you've learned how to make guitar leads, you can learn to make any leads. This is a lead that's got stereo jack on one end and it's got an XLR on the other. It's exactly the same set of skills, different connectors, but fundamentally the same thing. So enough talking, how do you actually solder a guitar lead together? Well, I've got to move the camera over here and then we're going to find out. Before we get the soldering iron fired up, let's just have a quick look at what is inside a jack plug. So, I've got this outer screw in jacket here. Let's pull that back. We've got a plastic sleeve which protects the connectors inside, the metal parts. And then we've got a central core and a screen which are soldered onto the metal parts of the plug. And that is all there is to it, really. So really what we have to do is we just have to attach this part and that part, and that's all there is to it. This is why this is one of the most simple soldering jobs you can actually do, but it can be a little bit tricky if you don't know exactly the right order to do things. So I've got a fresh piece of what is this? I'm filming this upside down, so this will be upside down for you. That's Van Dam Pro Grade Classic XK instrument cable. There you go. I'm going to take a Stanley knife, as I call it in this country, because I'm British, and I'm going to cut around about 2 centimeters, or most of an inch, for the North Americans. Now, obviously, you want to be, anytime you're using one of these blades, you want to be pretty careful. So I'm fully aware that there's metal inside this cable, so if I apply pressure in this direction, I'm probably not going to cut through straight into my thumb. But what I'm doing basically is I'm placing the blade on the point that I want to cut, and I'm applying a little bit of pressure, but not too much, and I'm just going to rotate the cable a little bit, and you can see it's just kind of cutting into the cable there. What you're not aiming to do is cut all the way through, you're just kind of scoring around. And then, once you've done a bit of that, you can kind of give it a bit of a wiggle. Just need to do a little bit more of that, because It's a bit harder when you're looking down a camera. Okay. So we've just scored around that edge, and we're going to wiggle the cable a bit around, wiggle it around, give it a little twist, and now it's come loose. So I'll just kind of pull that off. So inside, the first thing you meet is a bit of usually copper screen. Sometimes it's kind of woven together into a sort of cross-hatching, so it doesn't necessarily pull to one side that easily. Sometimes, if your cable has got, it'll have a kind of crisscross pattern on it, you might have to get, actually a knife isn't the best choice, but anything a bit like the tip of some pliers or a toothpick, something like that, and you just have to kind of push up through the kind of woven bits of copper until it's all spread apart like this. And then what I'm going to do is I'm just going to kind of gather that all to one side and just give it a little twist like that. Doesn't matter which way, clockwise, anti-clockwise, really up to you. And we'll just leave that. We'll just pull that back, just like that, just for a minute. And now we come to the inner core. And on this particular cable, every cable's a bit different, but this has got a kind of a black plastic cover, and I believe there's a sort of polythene inner core. I'm not quite sure what material that is. Someone will probably correct me in the comments. Now, wire strippers. We can certainly use wire strippers to kind of just nearly chop my finger off there. To get at this. I personally, the problem is that when you grip that with the wire strippers and you pull, you're probably going to pull this inner core through the cable a little bit. So you're going to sort of stretch it, which I don't think is very good. And you're also going to it's also going to mean that this inner bit is going to be longer. It's going to be sticking out more than you expected. So what I suggest if you are going to use wire strippers, get some other pliers and just kind of grip it with the pliers. Personally, I can't be bothered with that. I tend to just use the same technique that I just used. So just applying, again, just leaving a little bit of a gap there of about 3/4 of a centimetre, or whatever that is in inches, 30 billionth of an inch. Just going to score gently into the cable until you feel until you meet the metal. Don't cut any of that copper inside. You're just gently scoring it, rotating. You can see it's coming apart. Just taking your time, bit of patience here. Make sure you've got a sharp blade, and then that piece will just pull off. You might lose the odd strand. Not really worth worrying about, but in this case I've done that more or less perfectly. What we're aiming to do, as we saw on the finished plug, which I've now thrown to one side, is that central piece wants to go through that hole there, like this. I'm just showing you, I'm not doing this for real right now. That goes through that hole, and then this copper, the larger copper piece, the screen, is going to connect to the lower part like that. So we're sort of aiming for that sort of thing, approximately. Now, because I've got a bit of experience, I've cut. That's the reason that black part is cut to that length. So those kind of metal pincers there are going to grip the cable at that point. You want screen all the way along from that point right up to where the core is going to connect with its soldering point, soldering cup, and then that's where the copper gets exposed. So now this is the bit that's really easy to forget. Before you actually solder these things on, you want to take this bit and slide it onto the cable. You can even do that before you've cut the cable expose the copper inside, but I actually forgot in this case because I was thinking about other things. So now I've made this a little bit difficult for myself. You will inevitably forget to do that at some point because everyone does. And also the plastic sleeve goes on there as well. Do not forget to do this because worst case scenario, you will end up having to desolder this part in order to get these sleeves on, which is not very good. It's not much fun, it's infuriating. The next thing to do is we just want to trim these, just want to make sure we haven't got too much of these cables. So what I'm aiming to do when I do actually attach this, I'm going to poke it through the hole. I don't want this so much extra cable on this core that it's going to bend down and touch the shield connector, because that will short the cable and it will stop it working, and that's no good for anyone. So that's a fairly hefty piece of copper in there. Sometimes they've got pretty flimsy, tiny little cores. I'm just going to retwist that the other way. And you might like to just kind of fold it back. And let's see if that will go. Probably folded. Oh, it will go through. Okay. Fine. Fold it back then, in that case. Now the screen will almost certainly need to be trimmed back, because again, if you've got this extra floppy bit of cable here, you don't want that flipping up and touching the core, because that will short the connection and stop it from working. So I'm just going to trim that off. I've got some little clippers. As a guide, more or less, keep it the same length as the core. Just like that, just trim that off. All the time, you want to just make sure you haven't got any loose strands. You want these to be really nice and neat and tidy, at least at this point. And now, it's time to fire up the soldering iron. Now this soldering iron, nothing special about it. It's an 18-watt soldering iron. These cost, I bought this from Maplin a few years ago. Maplin's gone now, but couldn't have cost more than 15 quid. The thing that is handy about it is it's got quite a large tip on the end. You can see that relative to the size of the cable. And that's useful just because we're not micro soldering here. These are relatively large pieces of wire. You do need to heat them up. If they don't get hot enough, you won't get a decent enough connection. So, here's our solder. This is lead-free solder because we're in the EU. And we're not allowed to put lead anywhere near us. So I'm actually just going to chop off a little bit of that, just so I don't have to handle the whole reel. There we go. Now, little tip on using a soldering iron. Almost burnt myself there. The soldering iron stand comes with a sponge, and the sponge is what keeps the tip nice and shiny and clean like that. You can actually see, because it's a hot bit of metal, it gets quite warm. I'll try and get that in focus as much as I can. There we go. And it gets kind of tarnished. So, just a little tip on treating your soldering iron well. Before you even use it, you need it to be clean. And you can see the solder is kind of bubbling up a little bit on there, so that's not a clean tip. It's effectively sort of rejecting the solder. So I'm going to solder that up, wipe it off on the brush, and you can see now that is much cleaner and shinier, and if I apply solder to that, it just goes on straight away. So that is a clean solder tip. It'll stay like that for a short amount of time, a couple, maybe 30 seconds or something, a minute. But you want to just keep an eye on that, because if you're new to soldering, usually the thing that's a problem is you go, oh, my solder's not sticking. Why is that? And usually the reason is because the tip is not clean. You must keep your tip clean. So I've got this in a vise, just bring it a bit more into shot. This is really the way that I like to do it, just because the vise stays exactly where I want it to be, and I don't have to worry about things slipping. You do get these kind of helping hand things, the little crocodile clips on. They're fine. I don't really get on with them that well because I find that they just kind of wobble about a bit, and then as you sort of you set them up, they stay in position. But as soon as, so just applying a bit of solder there, just to make sure the tip's clean. As soon as you start applying any pressure, they just fall over and then fall on the floor, and then your soldering iron falls on you, and then you get burnt, and then you get sad because you burnt your fingers. So what I'm going to do, this is called tinning. I'm going to tin these cables. So I'm just going to apply the iron just to the cable, just for a second, just to kind of preheat it. And then what I want to do is get a little dot of solder on the iron there. And as you can hopefully see, the copper is just kind of taking up the solder. And what we want to do is we want it to flow through the cable. We don't want to be applying loads and loads and loads so we get big blobs like that. Don't want blobs of solder, we just want something nice and neat. Just applying a kind of a preparation of solder. And this is called tinning. And again, just on this connector, just letting the solder flow through the strands. See, I didn't preheat it enough there. And just be patient. It won't melt straight away. Once it goes quickly. And that should be just quite nice and neatly tinned. You can see it's silver all the way around, so the solder is covered all the strands. It will still be hot. These things stay hot for a little while, so you do want to just be careful. When it comes to actually preparing the connector, again, I like to stick it in a vise. You can see I've kind of, well, I probably can't actually see this, but I've kind of scorched this vise because I've been not using it carefully enough. So we tinned the connectors on the cable, and now we want to do the same with the plug. So again, heating the iron up, a little bit of solder on there, a little brush, make sure it's clean, make sure that tip is clean, and we're ready. So, same technique as before, heat the surface first, and then I'm going to push the solder in between the iron and the surface there. So we're just getting a little island of solder on there. We're not layering it up loads and loads and loads, and you can see it kind of becomes liquid, and then it dries. With the top connector, I think I'm actually just going to leave that because the clearance of this piece of, remember it was quite tight, so I want to make sure that I don't bung up that hole there. I'll just turn it sideways, so this is going to be quite hot. Yeah, this is why it's nice to put the thing in a vise rather than hold it in your hand. You can hold the plug and solder, but you'll probably burn yourself. If you don't have something to put the connector in, and really everyone's got something, because if you play electric guitar, you've got guitar pedal, and you can actually use this socket if you want, although bear in mind the socket will kind of leach heat away, and it potentially might make things more difficult because it'll be drawing so much heat away from what you're actually trying to solder. So just bear that in mind. Now, when we're doing this, it's also important that we don't heat up, we don't have the iron on things for ages and ages and ages and ages. With guitar leads, it's actually usually fine because there's not any, there's not sort of bits of plastic to melt. But as soon as you get onto things like XLR leads or sockets of any kind, there's usually plastic parts that the metal's in contact with, And if you can see, this is the tricky part. It's just getting these cables in the right spots, because whichever way you do it, see, I think I've got a little bit too much on the end of that. Remember, you don't need vast amounts of the cable in contact. You just need a little bit. And I think this piece here on the core is just fractionally too long, so I'm just going to snip the end off. And now when that goes into the hole, there's no danger of it getting in contact with anything else. The important thing is that there's a good amount of solder in contact with the surface, and that is to maintain a good contact. But with things like guitar leads, more than anything actually, like things that get yanked around a lot, you want to make sure there's a good kind of, if you like, a mechanical connection, because that means that it's going to last longer. Okay, so I've just got a little bit more solder on there, and all I need to do now, so I'm just getting it in there, and I'm heating the surface of the plug. I'm heating the lead itself. And again, I'm just getting a little impatient there, so I'm just going to remind myself to be patient. Sometimes it takes a second. This piece of metal is quite large, so it will draw the heat away. So I'm actually just going to heat it from the underside there to make sure that piece of metal's hot. And then it's not really making a great contact actually. So a little bit extra. Even though I'm heating this from the underside, it will most likely melt that solder. Yeah, there we go. There we go. And sometimes you just need to manipulate the lead, the main lead itself, just to make sure that it kind of wriggles into the right spot. And then the top piece should be a little doddle. Okay, I'm just heating both surfaces together, feeding a little bit of solder in. Remember, I didn't tin this top piece, so I'm just semi-tinning it as we go. Not bad. Okay, and then the final thing to do, get the pliers, just squeeze this bit for strain relief purposes. I imagine those magic special tools that people have for doing this. You just manipulate it with pliers, squeeze the parts together. This isn't the ideal set of pliers for this job, but it doesn't matter. You don't need to go and spend huge amounts of money on specialized tools, expensive things. You can just use whatever you've got. And now I've just brought these connectors over. All you need to do, just close that up, screw it in, and you'll find that the plastic sheath, a little bit of a squeeze there, will cover all of your work up, which stops it getting in contact with the outer screen. And there you go. Screw that all together. That's your guitar lead. Finished. And then all you need to do is just do the same to the other end. Hope this has been informative. Hope you've enjoyed the video. And see you next time. Bye bye.